Well, I appreciate you being here. Go ahead, just, yeah, feel free. We're just starting, so we are planning to be here for 45 minutes. I'm thinking that's the first talk or one of the first talks, so I appreciate you being here. Just listen to me. Yeah, go ahead, guys. So let's maybe wait 1 or 2 more minutes until everyone settles in, and then we'll start. I think there are a couple more seats in here in the front. It's not dangerous, don't worry. There are still two more seats in here. There are, yeah, some seats in the corner. All right, well, thanks. I really appreciate you being here. I'm Dmitry Shevlin. I'm going to talk about Kubernetes growing pains today. I'm a solution architect at Spectro Cloud. I've been involved with various infrastructure bits for a number of years now, so my goal here is to share with you what I've learned over the years, and I'm hoping this is going to be useful for you so that you'd be able to apply some principles that I learn in your practical life. So I'd set up for easy talk, so relax. I'm just going to basically share what I've learned. No requirements, just sharing of experience. I've been doing this now for more than 15 years, and I say in the last 5 years, the most extensively again with Kubernetes. So I've called my talk a number of growing pains and how to solve them, right? So the first of all is why are we talking about, why have I chosen this topic, why are we all here? So Kubernetes is growing, it's pretty much everywhere now. And it's difficult between various specialists and professionals, especially when we are isolated, not to share. So sometimes we read forums, sometimes we send emails, sometimes we communicate with each other, but we may not be aware of as that like industry has problems on its own. So sometimes there are challenges in configuring clusters, upgrading clusters, just it's time consuming, it's annoying, it's frustrating, to be honest. So what happens is that when you work with Kubernetes clusters, when you provision them, at first it may sound like easy, straightforward, but with time, we accumulate issues, right? So it's like how we update them is when you're running a Hello World cluster on your laptop is one thing. When you're running a production cluster in HA with the various cloud providers, that's a different things. Okay. Now, if with time you spend more and more effort onto just implementing routine tasks, this is where you would implement, this is where you would suffer, right? So what is it that pain? Why I'm talking about pain and what is it pain? So imagine you're starting just a cluster and it's easy. Inevitably, you will install some software on it, you will put some applications, you will migrate it, you will update it, you will back it up, you would recover it. So with time, that all the routine tasks start to consume more and more of your effort. So what does it mean? That you don't have time to put it into interesting tasks, to develop yourself, to do something useful for your company, for yourself, for your hobby project. So what I gathered from my experience, from my personal experience, there would be 3 major goals, right? 3 major pains, which we are aiming to eliminate or at least improve. So first of all, it's developer productivity, right? From what I've seen, well, most of the Kubernetes cluster installations are not made for the sake of it, right? You eventually aim to run something onto it. You eventually aim to run some software applications. Your goal is to run something useful onto it. And eventually, it may be so that you're not the only person using these clusters, right? So there will be your colleagues, there will be some DevOps guys, there will be some developers, some engineers, some pure developers. Some of them are not involved with Kubernetes at all, so they're not really bothered about what's the infrastructure background. And with the system growing in complexity, the development process becomes less efficient, because in order to launch something, this is going to be kind of complicated. I'm going to talk about this slightly later in more details. Second pain is a number of clusters. So like I briefly said, one thing is when you launch a virtual box on your machine and it's a hello world cluster. Another thing when you have to manage 3 environments, because from quite often there is development, stage, and production. There is multiple clouds. They all have their own specifics. Sometimes you'd have to update them. Sometimes you have your applications with requirements, with contradictory requirements. Sometimes one application A may require Kubernetes version 1.22, application B may require 1.23. They can't coexist on the same cluster. You'll have to multiply this cluster, so inevitably a number of cluster grows. These brings their own pains. And the third one is edge. So yeah, that's a specific beast. We are going to go into details. So now I just wanted to ask you to have a think and just to analyze. If you can help me, maybe who of you has experienced like first pain is with your hands. If you can just maybe show who of you, maybe a third. Okay, fine. So with a number of clusters, when the number of clusters grows to double digit, so anyone? Okay, maybe a half. And edge. Has any one of you started working with edge with a huge number of devices? Okay. That's probably not yet. Fine, thanks. That's the only thing I was intending to ask. So now let's go into details. Developer productivity, okay? So from those running codes, it's not really important what's running behind the scenes, right? They just want to write code. Sometimes we just want to write and test something. Sometimes you just need to change one Boolean value. Sometimes you just need to change one number, 3 to 5, right? Now, from infrastructure world, what we created the whole shebang of procedures. So that means that when you want to launch or maybe a compile or make a new commit or do something, you'd want to test it quite quickly, right? You're not that bothered that for you, in order to increase some limit from 3 to 5, there is some sort of CI/CD pipeline that will need to be launched. The cluster will need to be recreated, and all this will consume minutes and sometimes up to a couple of hours. So this is one of the real world examples, which was told to me by one of our customers, is that they had to actually wait a couple of hours just to make a tiniest change. So just to change, let's say, background in Grafana, because of all the controls, all the checks, because of all the post-commit hooks, So the system has grown quite complex. The net result of it is that the developers become quite less efficient in what they want to do, okay? This is just because, well, this all needs to be done. This all must be done. Now, as you see, not everyone is happy with CI/CD, right? So, yeah, I was told to bring memes, so there will be memes. The pipeline, sometimes they're quite complex. So sometimes they're quick, sometimes they involve downloads of stuff, recompiling stuff, sometimes the hard disk is slow. So therefore, what we at the infrastructure team provide to our colleagues in development world may take time. Them, from their perspective, they also have their procedures. So sometimes they want to make just a small change, but sometimes there is a different version. Sometimes there is a different branch. Sometimes there is something else. So the whole system has grown quite complex. Now, last points onto the problem, and then I'm going to proceed how we're going to solve this problem, right? The whole point of me being here is to first identify and to share the problems I was able to find, and the second point is to propose some principles, and then maybe give examples of how we solve these problems. Now, developers grow frustrated of all these processes of creating, infrastructure clusters. So therefore, it's very tempting just to test something onto the laptop, because laptop is here, it's quick, it's fine, it's under full control. So therefore, it's easy. Now, unfortunately, it's quite complex to mirror the production environment, right? So that you can launch a binary file, you can compile something, but you will never be able to reproduce the whole environment, just because there is a number of monitoring tools, there is a number of logging tools, there is a security tool. So in order to reproduce all that, first your laptop has to be quite a powerful one, right? So let's say you need to be running a lot of associated software. And second, there will be some licensing issues, right? So it's like sometimes that the vendors, when they sell software, you can only use it in a certain perimeter. So it may be in a data center, in the cloud, but you're not allowed to use it into all the laptops. Sometimes there may be architecture problems, right? So right now, I'd say the predominant architecture is x86, but still there is some ARM boxes, there is PowerPC boxes. So for various reasons, it's not that easy to do. So let's take a look at the solution, at least as principles. So the principle, what I'm recommending to you is to use something within your Kubernetes clusters, which are running inside data centers or hyperscalers, okay? So that's not to migrate to third-party tools, but instead of creating full-blown clusters, the idea is to create small clusters under full control of developers. So the principle here would be virtual clusters, right? So in order for developers to be able to be more efficient, what I suggest we all do from infrastructure and from development point of view, we delegate an ability to create quickly virtual clusters which would be compatible and which would run exactly on the same hardware and with the same software stacks as main clusters, except that it's better than the local laptop just because, well, it will be running inside the same platform. It's supposed to be run in the future, all right? So the idea is you could create a virtual cluster quickly, and when I say quickly, I mean a single-digit number of minutes. So in an ideal scenario, that would be 2-3 minutes. In real world, that may take 7-8 minutes, but still, that's not 2 hours, that's not a day, that's a single-digit number of minutes, all right? So that gives you an option to create and therefore to remove the virtual cluster quite quickly. So that's a principle. Now, what we did with a company which I work for, Spectro Cloud, we took the open source solution, which is called vCluster. All right, you could just take a note or search for it just to take a look how it works. And we incorporated it to make it enterprise ready. Okay, so we made it easy to consume. We created our own UI, which you could use to create the clusters, to remove the clusters. So you could manage it from Terraform, REST API, or UI if you want. And it's compatible with all the infrastructure providers, with Amazon, obviously with Microsoft, with Google. We add airbag policy on top of it, and we do a self-healing. So all this works also for virtual clusters. So that means that you could create your clusters quite quickly. So that's an approach that I suggest to make developers more efficient. All right. So you would give them an option to create their own clusters, so they would be able to have them and have full control of them. Maybe even order them. Maybe just create some sort of a template, and therefore order them, play with their code, make commits, and send whatever, make whatever changes they want to, and therefore and later then remove them. Okay. So that's in a nutshell the first issue. Second one, the number of Kubernetes clusters. So these numbers come from our own research. That's basically what we learned. So that Kubernetes state is already quite ubiquitous. Okay. Right. Let me just stop for a second. So I'll probably just leave you settle it in your head. So if you have any questions, just maybe have a think, or yeah, either ask a question or ask at the end. That's the first part, the developer productivity. Okay, second, so out of 3, number of Kubernetes clusters. So this is, as I said, this is our own research. So this comes from our numbers. Not only Kubernetes is already present into infrastructure state today, but it's also growing. That means that tomorrow, 2023, we'll have more clusters rather than we have today. Okay. The consumption of Kubernetes also increases. That means that even though sometimes already today in 2022, I've seen vendors sending software as a containers. So whether you want it to have Kubernetes in your state or you don't want, sometimes you just don't have a choice. Now, all the researches, I also read personally, Gartner researches and other researches show that this process is going to continue. So we're going to have more containers, more Kubernetes clusters. We're going to have more growth. Okay. This growth is going to be fast. So, well, obviously, it's very difficult to make any predictions because, well, numbers, you see, it's like it's quite a chaotic process, but still, how exactly? So we can give you some estimates. So the growth is definitely going to be there, and it's going to be significant. So what this means for you specifically? Like I said, you don't need to have any special knowledge or maybe just an hour of 2 of reads when you want to create your first cluster on your laptop, right? You could use kubectl, kubadmin, doesn't really matter. You could create a cluster quickly. You could launch it in Hello World within a day. If you haven't read anything about Kubernetes at all, it's easy to start, right? There is no challenges in here. However, when you go in production, when you go further, when you deploy it for the company, sometimes you will be requested to have more clusters. Sometimes they will have requirements to have support multiple environments, multiple hyperscalers. You will have this growth that will inevitably hit you. Okay. Now, why I'm here and why I'm talking is just because I've spoken across a number of years with dozens and probably already hundreds of customers, and therefore I just defined and from experience, I'm telling you that even though if you're having maybe 3-4 clusters today, which is often the case, okay, you just have, well, production more or less, you have development which you don't touch, this process is going to grow, okay, well, for various reasons, but this process is going to grow. Now, with growth, your management strategy, it's better to change it. So it's better to improve it and it's better to change it. Let's say if you managed clusters 10 years ago, probably, or maybe 15 years ago, it was sufficient just to use command line. That was manageable. You had single-digit number of servers. That was fine. Now, with growth, it's changing, right? So as soon as we went from pets to cattle, there were tools like Puppet, Ansible, Chef, Terraform, all of these languages allowing you to orchestrate, allowing you just to command dozens of servers at the same time. Same thing is highly likely to happen in Kubernetes, and we are seeing it's happening already today. If you have only 1 cluster, 3 clusters, maybe 7 clusters, depends on how much time you want to spend and how much of your personal time, of your working time you want to invest into manual management. It's doable to use its standard tools, which are baked in. Let's say kubectl, there is a pretty nice tool called K9s. Yeah, I have nothing against them, right? These are perfect tools. Except that when the number of clusters goes to double digits, whether it's going to be 20, 30 at some point, it's going to be complicated to manage all of those clusters, right? So the thing is, you may not want to have this growth, but sometimes, like I said, you have contradictory application requirements. Sometimes you have various development teams requesting for Kubernetes clusters. Sometimes when you're successful, when you can quickly deliver Kubernetes clusters, this knowledge propagates within the company, and you have more and more colleagues addressing you and asking you to create clusters. So therefore, I mean, if you want to help them, if you want your department to be helpful, you have to request to these. You have to respond to these requests. And so we just thought, so if we are from now for what, about 10 years managing clusters using tools like Puppet and Chef and Salt and others, and why not to do the same with Kubernetes, okay? So the principles I'd suggest how to approach all these problems, how to approach all the clusters as a number of clusters. First, the approach needs to be declarative. So you wouldn't want to create your Kubernetes clusters as pets, okay? So you'd want to define something which we call specifically at Spectro profile, but the idea stays the same independently of which software stack you use. So you'd have to define it somehow. So you'd have to define a template based on which you'll be creating your clusters. Yeah, sorry, can't do anything with it. Now, cloud agnostic. So that's something we recommend because most of, well, I wouldn't say most, significant chunk of our customers use one cloud providers, but there is also an intention or plans. Sometimes they are theoretical, sometimes they are practical, depends on whether there is a commercial push, whether there is a technical push to use a second cloud provider. Now, if you invest into making your infrastructure compatible with one cloud provider, and again, I'm not kind of pushing you for anyone, it may be your specific one, you're inside your on-prem provider, maybe one of the 3 hyperscalers, Amazon, Microsoft, or Google. But independently of which hyperscaler you'd use, if you invest in just making your infrastructure compatible only with this cloud provider, then all the future migrations are going to be challenging, because at the end of the day, they are offering similar service, but the devil is in details, because to consume those services, if you already made your configuration specific on the consumption of VPCs or IP addresses or EC2 machines or containers or AKS or EKS or GCP, GKE. So if you made your infrastructure compatible only with this stack, extending this is going to take a lot of time. And most probably you're not going to get an approval because, well, if you've just spent, I don't know, half year on making your infrastructure compatible with a cloud provider, later it's going to be extremely difficult to extend it. So therefore you're going to be hooked in, so you're going to be locked in. Now, whether it's a good thing or bad thing, that's probably up to you to decide. I'm more pushing for more or less for a vendor-neutral solution so that you would keep your freedom. Third principle is single pane of glass, right? So that's something that would allow you to take a look at what's happening, just to simplify. Again, you can try to build it your own solution, as your own solution, which I really don't recommend, but inevitably you'd want to have something which you would see all of your clusters, or like the vast majority of them, in somehow convenient way, so that you'd be able with a quick look, understand whether something is going wrong, what's the state, what's the overall state, what's the majority of, let's say, your Kubernetes versions, what's the majority of loads of them. You know, having something like a tool which would allow you to have a quick control, like a human control. So that's not replacing anything. Here, what we suggest, and again, when I say we, that's a company I work for, but Cluster API is an open source solution, so this has nothing to do with us. This is a solution that is there, that has been available for everyone to use, and this allows you to kill, in this case, these 3 birds with one stone. Well, Cluster API allows you to kill 2 birds, the first 2, so we add a single pane of glass. Now, let me give you an example, all right? So this is how our interface looks like. So this is when you will be creating a new cluster. So we support multiple cloud providers, so we are cloud agnostic from day one, right? So we're not pushing for any cloud to use. And the UI is going to look something like that, all right? So this is an example of creating a cluster. So how the cluster definition is going to look like. So that's something that we propose. And the second one is just a number of clusters created. So as you could see, maybe it's too small, but that's just a number of Kubernetes clusters running on various environments, including Amazon, including Azure, including Google, on-prem, edge. So that's something what you could see. That's something you could click. Yeah, that's basically it, right? So let me make a short pause here. This was a second pane. If you have any questions, yeah, go ahead. I think there's one at the back.
In one of the slides you had like infrastructure as code also for the Kubernetes part. Mm-hmm. So is that more of a thought, or do you have a tool chain or something which is already in practice?
We have a solution that is already in practice. So now I'm here to share with you problems and solution principles. So I'm trying not to push too much specifically for our solution. We do have a solution in practice to do that. So we do a full declarative approach. So if you want to, we could take talk later, or if you can come to our workshop tomorrow at 3 p.m. I'll show you how it works. But yeah, we do have a solution in practice. It's working. It's production ready. Mm-hmm. All right, one more, and then we'll go to the edge.
Can you just shed some light on what the palette is, because I have missed that. Is it some internal product you guys use, or this is something you open source, or this is something your company sells? What is it?
Sure. So Palette is something, it's our product, right? We sell the product, it's available as SaaS by itself. So it's something that is there, that is available for you. It has various open source elements. So the SaaS element of of the solution itself is not open source, but there are various bits and bobs which are open source. Let's say mass provider is open source. There is open source operating system available for Edge, which I'm going to talk about later. But yeah, that's a solution that we propose for managing, for upgrading Kubernetes, for managing all of the problems which I'm talking about. Yeah, if we have time, I'll show at the end. I just wanted to cover the problems and then principles, and then if we have a couple of minutes, I'm going to show the solution itself. Okay. Yeah.
Hello. Yeah. In one of the slide, you mentioned that you create a basic cluster and you make another cluster inside the cluster. But if I want independent clusters, is that possible then? Because
it is possible. It is obviously possible. That wasn't just the nature of my talk, because there are many solutions out of the market that allow you to create multiple clusters. Of course, our solution, and you can create it without our solution. We simplify this, but yeah, it's obviously possible to create hundreds of clusters and dozens.
they are all related to each other, or at least there's a dependency.
You can have various profiles. So you can have profile 1 and create clusters 1, 2, 3 based on profile 1. You can have profile 2 and create clusters 4, 5, and 6, which will depend on profile 2. So it's not one profile.
But that means something like inheritance.
Not necessarily. You can inherit. So child clusters, virtual clusters, will inherit properties of a host clusters. Host clusters can be completely independent. They may not have anything to do with each other. One may be Edge, another one may be AKS.
Okay.
Different Kubernetes version. So you can use inheritance. You don't have to.
Okay. Okay. Thank you.
Pleasure. All right. So let's cover the Edge. So not many of you have faced these problems yet. I'm just going to talk about future. So bear in mind, Kubernetes changes a lot. So yeah, maybe if we talk in a year, the priorities may be different. I'm going to talk how we see them right now, December 2022. So Edge at first looks like something similar to data center, right? And when I say Edge, I mean remote locations. So let's say shops, fabrics. Sometimes they have decent internet connection, sometimes they don't. Now, it's difficult. So the Edge itself, what is it? It feels like from infrastructure standpoint, from infrastructure point of view, it feels like it's the same as data center, because essentially sometimes it's ARM, but sometimes it's x86 machines. So it doesn't feel like something bad. However, in reality, first, the internet connection may be significantly worse in a data center. So therefore, sometimes there may be connection cuts for a number of minutes, hours, sometimes days. Second, if something goes wrong, in edge locations, quite frequently, there is no skills, right? So if we are talking about, let's say, shops or organizations with redistributed sets of shops, let's say here in Germany, it's Rewe, for example, right? Sometimes there are shops where there is just no local skills. The local mechanics, the maximum they could do, they could just plug a device. They won't be able to debug it. They won't be able well, maybe they will be able to reboot it, but they won't be able to connect any monitor. Let's say there is no monitors, right? And that's a third problem. That's a hardware difference. If you run in a data center or in the cloud, it's quite easy to get direct access to the device should something go wrong. I mean, you press on a virtual screen, or if you're in a data center, you just physically plug the screen. Now think of edge location. Sometimes there is a small device. There is Ethernet cable or Wi-Fi. More often it's Ethernet cable. That's it. There is no monitor. It's just imagine a shop somewhere in the far away from the city. You're not going to send a specialist with a monitor each time, because normally a number of locations is huge, right? So it would be thousands and tens of thousands of locations. Or let's say petrol station, okay? You can't have an IT guy capable of debugging a Kubernetes cluster on each petrol station. And if you are going to send this guy, well, imagine how many stations you have across the country, across Europe, across continents. You would have to have a lot of guys driving all the time with monitors connecting. So that brings a lot of problems. Now, what I'm suggesting you how to solve these problems. Well, first of all, I already mentioned briefly that the solution for installing Kubernetes on the edge needs to be declarative. And sometimes there is a desire not to install Kubernetes at the edge. That's why I started with numbers, showing you the number of cluster grows. So therefore, today, it looks like Kubernetes will make it into edge, and you will have to install Kubernetes clusters on the edge. More often than not, this is going to be a small cluster, so it's probably going to be just one node, it's going to be one device. but still there will be some Kubernetes running. That's why I mentioned about numbers, and that's why I mentioned about being able to declare clusters, okay? So you wouldn't want to install cluster all the time, like manually. You would want to have something like a profile, declaration, YAML code, description, anything allowing you to do this, to multiply this, to make a repetitive process, okay? Second, you probably wouldn't want to treat your Raspberry Pi or Intel NUC or any devices like pets. You'd want to reinstall should something go wrong. So you'd need to be able to provision full stack from scratch. So your solution, it should just work from plugin. Like imagine a device coming from the factory. Okay, it's empty, nothing into it. No operating system. It's just that it has a hard drive, but that's it. So your solution needs to install full-blown operating system plus CNI, CSI plus Kubernetes. So from day one. Third one, if possible, your solution needs to be as simple as it can be. So therefore, there are many companies. There is Canonical with Ubuntu. There is other companies pushing a small operating system with a small footprint, allowing you to not to mess too much. So we push Kairos as an open source solution. This part is open source. You can just Google for it. The fourth one. Low touch onboarding means exactly what I showed you. So the whole installation happens that you plug a USB device, and then you plug the device into network, like power network and Ethernet. That's it. So no more intervention required, no more press enter, type IP address, do something. So the luxury that we had in data centers and the luxury that we had in the cloud is not really available in the edge. No one is going to imagine a cashier. So the best thing they could do is just to plug the device. So your solution needs to install without any human intervention. So you need to either pre-configure or arrange DHCP so that it would get an IP address, connect to the motherboard somewhere in the center, so to your solution, and then get all the updates and then be connected in case you need to push new updates, application stack, all that still stays with us, okay? The last thing I wanted to show you here is an AB upgrade, because it's easy when you do a virtual machine or a physical server upgrade. Sometimes you have, so with cloud, you just recreate the VM. You trust that cloud is available. With your own hardware, for Dell, you have iDRACs, for HP, you have iLOS, all these magical mechanisms allowing you to recover. Because imagine you patch the system, you reboot, that's it, the server has gone, it's not responding. So you have a backup, you have a backdoor, right, within your data center or in the cloud. Well, guess what? In the edge, you don't. Because if you rebooted this small device and it's gone, that's it. I mean, you need to drive there, and then we are back to the first point, multiplied by the number of locations. Some of these locations are remote. The recovery of failed server is a pain. That's a huge pain, and that's what we want to achieve. That the solution of this pain is to minimize the downtime. So when we do the upgrade, and then again, like I said, I'm talking about principles. If you were going to do an upgrade, bear in mind that you'd need to do something like an AB upgrade. So you'd have two partitions, and you'd have an auto recovery mechanism. So if the device wasn't able to boot and to retrieve and to get something from motherboard, it needs to be able to get a rollback and switch back. So to do a rollback and return back to something that works. So you'll be able then later debug it from outside, remotely, from Kubernetes clusters, launch a container, do something, do launch bash remotely. But what's quintessential, what's crucial here is to keep connectivity. So that's what we need to do. That's what we recommend. So now back to pallets. So back to what we suggest. We support this solution today. So that already works. You can already provision Kubernetes clusters. You can plug the USB device into edge device. You could install it. It would automatically install operating system, retrieve Kubernetes version, retrieve CNI, CSI, start the cluster, and report back saying, "Hi, I'm there. I'm now ready to retrieve containers. I'm now ready to install an application stack." So we still have a couple of minutes. Right. Let me summarize as of what I want you to take from this talk. Then maybe questions, and then I'll do some demo if we have time. First, there are pains. We are all experiencing these pains. The amounts of pain and the suffering can be different, but there are the recommendations. So what I want you to talk from this talk is not to do it yourself. I mean, obviously I'm biased to use our solution, but in reality, just look for any solutions on the market, because the problems you're experiencing, probably you're not the only one, right? So the Kubernetes is built as an open source, right? So you could just play with it. You could solve all of the problems yourself, but the trouble is the amount of time and suffering and eventually skills is quite significant one. So that the recommendation would be not to solve, not to reinvent the wheel, not to just to try to solve it everything yourself, even though you can. But in order to be more efficient and to concentrate on the tasks that bring more value and that are more interesting, quite frankly, just benefit from solutions of others, right? Just look at the internet, look at what the solutions are there. So we are actively pushing Cluster API, and we built our solution based on Cluster API so that you'd avoid all of these pitfalls and you'd avoid this pain that you will inevitably get when you grow. Another point is day two operations. So just to clarify, when you install the cluster, you've installed it, right? You've probably installed an operating system, network, storage, blah, blah, blah. It's there. You've launched your first container. Perfect. So day two is going to come, well, the following day, right? Day two. So that means that whenever you'll need to upgrade the cluster, whenever you need to install some software that is required by security team, whenever you need to install logging and monitoring, so make it not as a proof of concept or value, but make it rather work in real production, deliver some value to real developers, to real IT infrastructure managers, to head of IT. So these are all the operations that quite often take a lot of time and are being forgotten, okay? So don't forget that install the cluster, that's not the last step. Tomorrow, we are running a workshop as to how to install Kubernetes on the edge, but we could just take a look at our solution. So if you're here, if you're available tomorrow at 3:15, yeah, feel free. It's somewhere in the plan here. Okay, so the last resources I wanted to give you, if you want to watch what we produce as a content, you can take photos of QR codes and go to the reports we had. You can go watch the webinar in your free time. Yeah. These are here, and maybe a couple of more steps is whatever we have is available as an edge research as of what's happening, and also state of Kubernetes production. That's also quite interesting. Now, last thing but not the least, if you want to, if you want to take photos, yeah, go ahead and take photos. Now, last but not least, if you want to win a Lego Batwing, so we have it installed on our stand. There is a QR code that you need to try. You just scan it. You will go redirected to Palette. You will create. It is free. I mean, it's up to you if you want to go and test it. No one is going to chase or push you. So yeah, take a photo. And I think with it, I'm sort of done. So I've communicated everything I wanted to communicate. So we still have a number of minutes, and I'm happy to answer any questions if you have any.
So you mentioned CIS operations on day one. I think a lot of challenges start from day two, right? Policy as code and being able to comply to various standards, whether it's geographic, infrastructure, application. A lot of things comes in. What do you propose as a code for doing compliances? So I don't have a concrete proposition for doing compliance. We as company, we don't specify on compliance. What I propose you do, you just create your Kubernetes cluster with code. So what we propose here is a declarative approach where you define your cluster based on YAML files. Now, it depends on what solution you have, to which compliance exactly you need to correspond. So hopefully they plan, I don't know. So we have some, let me maybe share my screen. There are providers on something like Terraform or Pulumi for Palette where you provision, or it's infrastructure provision separately and then you have this control plane to import it? So there is a Terraform provider. So let me show you if I just going to log into, I think I actually have it open somewhere. Hold on. There is a Terraform provider for Palette. So the easiest, and this is also open source. If you look for Terraform, Spectro Cloud, you could just find it. It's there. It's available. It's it's open source. It's quite popular one. So I think it's got more than 3 million downloads. So yeah, it's being used. So there is Terraform. That's the easiest one to use is Terraform. Palette itself, let me open it in here. So it looks like that. So you can create various profiles. You could create
clusters based on those profiles. You could create virtual clusters, which I talked at the beginning, right? So the creation of a cluster, it's like literally 2 clicks you would create nested. Yeah, sorry, I need to create first host and then choose a guest one. So that's like 1. And then I'm going to attach profiles. This is the declarative mode I was talking about. So I'm attaching the profile to a cluster, and that's it. So that was like 10 clicks, I don't know. But yeah, back to your points. In order to organize compliance, Terraform is available, especially if they publish their own Terraform resources. That's going to work like that. If they publish a number of requirements, well, then it's up to you to organize which the Terraform actions that you want to launch. Okay.
Thank you. Thank you for mentioning IPv6. Can you maybe spend 1 minute or something about your experiences about single stack IPv6, especially across different providers?
Here, I have to say my own experience is not that much. So, I mean, I can talk about something, but it's not going to be that this is not going to be a first-hand experience. So I know there are projects where we work with IPv6, but these projects as of today are mostly in the States, and I'm here in Europe, so I'm covering Europe. So therefore, I know that we support it. I know that obviously sometimes there is not a full-blown support from day one. That's why I mentioned IPv6. Unfortunately, my experience is just not enough, so while I can't talk first-hand, so we can make it work, but that's pretty much everything I could share. Yeah.
Okay.
Sorry. Yeah. Any more questions? Well, if there is no more questions, so thank you for attending my talk. Hopefully, yeah.
There is a question in the chat.
Sure.
So Alexander asked, why are you provision the cluster declarative, but use are not declarative as on edge devices?
It can be declarative on edge devices. The thing is, you see, it's difficult when I talk to humans and when I talk to devices, right? If I'm going just to launch one, like Terraform apply, and that's it, you'll see like hundreds of lines. Well, this is not going to show you anything. You won't be able to read it because we're all humans, right? So therefore, what I'm showing you here is UI. You don't have to use the UI. This was the whole point of my message, so that in real production, you will use Terraform, you will use REST API, which is also available. But that's not what I'm showing. So yeah, that's a good question. There is a discrepancy between what I show and with what I'm talking about. This is just to illustrate how it works. But yeah, Alexander is right. So yeah, thanks for the question. You're right. Behind the scenes in real production, you will be using Terraform. You won't be clicking onto it. It's available for edge devices as well.
Okay, and Henrik asked, what are the main reasons you would want to run full single node Kubernetes clusters on edge devices? I wouldn't. That's the problem, that sometimes there are requirements from software vendors. You see, obviously it's like I'm not willing to run something that is not necessary, right? So obviously, if this was possible, just to run on a container, and if you can just run one device with IoT device without Kubernetes, that's it. Do it by all means. The thing is, what I was talking about is that these pains will be when you will be imposed to use Kubernetes. And then again, Kubernetes changes quite a lot. In reality, sometimes, so what we see, what I saw, sometimes there is just a requirement, say an application vendor wants to have an independent Kubernetes cluster. If I managed to do without it, I would have run just one container, obviously. But sometimes it's just I'm forced. So yeah, these are requirements coming from outside, not just my desire to use. Okay, well, if there is no more questions, I'm going to stay here the whole 2 days. If you want to have a chat, yeah, feel free to go there, and bear in mind there is Lego, so yeah. Thanks, guys. Thanks, folks.